This is the 21st video and the second video on problems on triaxial loading and volumetric strain. The list of formulas used is already given in the last video. So here this is the question number 3. A metal bar 500 mm long and 20 mm in diameter is subjected to an axial pull of 66 kN under this load if the extension is 0.5 mm and change in diameter is 0.06 mm. Find Poisson's ratio and the 3 moduli. Now let us first calculate the Poisson's ratio. Poisson's ratio is lateral strain upon linear strain. Here lateral strain will be change in diameter upon original diameter, and the linear strain will be delta L upon L. So write it like this: bracket open delta D upon D bracket close divided by bracket open delta L divided by L bracket close. Substitute the value. Delta D is 0.06 mm, so 0.06 mm. Diameter given is 20, so this is 20. Then extension, that is delta L, is 0.5, so 0.5 delta L, and substitute the value of L, that is 500, so 500 mm is L. Start doing the calculations from here. Always while watching these videos, keep your calculators with you so that you become used to using the calculator. Suddenly in the exam you will not be able to use the calculators, and sometimes because you don't use the calculators properly, your answers goes wrong. So here, start from here, bracket open 0.006 divided by 20 bracket close divided by bracket open 0.5 divided by 500 bracket close is equal to, you'll get answer mu is equal to 0.3. You can write once again, bracket open 0.006 divided by 20 bracket close divided by bracket open 0.5 divided by 500 bracket close is equal to, so the Poisson's ratio is 0.3. Now let us calculate E. We know the formula delta L is equal to PL upon E, AE, and if we write it as E is equal to, it becomes PL divided by A delta L. So substitute a value. P given is 66 kilonewton, so bracket open 66 into 10 raised to 3. L is 500 mm, so 500, so PL, this is the PL, divided by bracket open area, bar diameter is 20, so pi by 4 into 20 square, and delta L given is 0.5, so into 0.5 bracket close. So put the bracket in the numerator and the denominator so that your answer doesn't go wrong. Start pressing the buttons from here. Take the calculators in the hand. Bracket open 666 exponential 3 into 500 bracket close divided by bracket open shift pi divided by 4 into 20 x square button into 0.5 bracket close is equal to. If you are not got the answer, do it once again. Let us try it once again. Bracket open 66 exponential 3 into 500 bracket close divided by bracket open shift pi divided by 4 into 20 x square into 0.5 bracket close is equal to, you will get the answer 200 into 10 raised to 3. That will be in Newton per mm square, or we can write it as 210 GPa. Now let us calculate this is the first moduli E. This is modulus of elasticity. Then we'll calculate G, that is modulus of rigidity. The formula is equal to 2G into bracket 1 plus mu, or G is equal to E divided by 2 into bracket 1 plus 2 into bracket 1 plus mu bracket first bracket close second bracket close. Substitute a value. E is 210 divided by bracket open 2 into bracket open 1 plus, and mu is 0.3 bracket first bracket close second bracket close. Start doing the calculation from here. 210 divided by bracket open 2 into bracket open 1 plus 0.3 first bracket close second bracket close is equal to, you will get the answer. G is equal to 80.77. Now E is in GPa, so this answer is also in GPa, so 80.77 unit is GPa. Then let's calculate the third modulus, that is bulk modulus K. So E is equal to 3K into bracket 1 minus 2 mu, or K is equal to E divided by 3 into bracket open 1 minus 2 mu, first bracket close, second bracket close. Substitute value E is 210 divided by bracket open 3 into bracket open 1 minus 2 into mu is 0.3, first bracket close, second bracket close. Take the calculators in your hand and do the calculations. 210 divided by bracket open 3 into bracket open 1 minus 2 into 0.3, first bracket close, second bracket close, is equal to, you will get the answer 175 GPa. If you don't get the answer, press the buttons once again and try it out. This is how you calculate the 3 moduli. 3 moduli is the plural of modulus. So this is E, modulus of elasticity, then G, modulus of rigidity, and the last is K, bulk modulus. Let's come to the next problem. A steel flat is subjected to biaxial tensile stress if sigma x is equal to 42 megapascal tensile. Determine the value of sigma y. If the strain in that direction is 0, then what will be the strain in x direction? Take 1 upon m is equal to 0.3. This is mu. E is equal to 200 kilonewton per mm square. Now we have given sigma x. We want to find out sigma y, and this is the biaxial stress system. So sigma z is 0, and we want the strain in the y direction is given as 0. If the strain in that direction is 0, means epsilon y is 0. Now epsilon y is equal to sigma y upon E minus mu sigma x upon E minus mu sigma z upon E, but as it is a biaxial stress system, sigma z is 0, and we have given strain in that direction, that is in the direction of y is 0, so epsilon y is 0. So we substitute a value here. Epsilon y is equal to 0 into bracket 1 minus E in 0 is equal to 1 divided by E. E is taken common into bracket sigma y minus mu sigma x bracket close. Sigma z is 0, so this term is not here. Now 0 is equal to sigma y minus mu sigma x. 1 upon E is not 0, so this bracket has to be 0. So 0 is equal to sigma y minus mu sigma x. So sigma y becomes equal to mu sigma x. Substitute value, mu is 0.3, sigma x is 42. Here sigma x given is 42 tensile and mu is 0.3. So 0.3 into 42, 12.6 Newton per mm square tensile. It is such a simple problem. Only thing is you have to understand what they are saying in the problem. If you understand the problem, then it is very easy. The calculations are not at all difficult. Next is, what will be the strain in x direction? Epsilon x. Now strain in x direction, epsilon x will be sigma x upon E minus mu sigma y upon E. Now this is also coming positive, so this is tensile and sigma x both are tensile. So 1 upon E is taken common, 1 upon E into bracket sigma x minus mu sigma y. So 1 divided by 2 exponential 5. This is given here, E into bracket open sigma x is 42 minus mu is 0.3, sigma y is 12.6 from here, and sigma x is 42 here. Okay, so take the calculators in your hand and do the calculations. 1 divided by 2 exponential 5. Don't press 2 into. If you press 2 into, this 10 to 5 will go in the numerator. So remember here, 1 divided by 2 exponential 5 into bracket open 4 2 minus 0.3 into 1 2.6 bracket close is equal to, you will get the answer 1.911 into 10 raised to minus 4, and you are getting this answer also positive. So this is also a tensile strain. Both sigma y is also tensile and the epsilon x strain in x direction is also tensile. This completes the problem 4. Let us go to the next problem. A steel bar 200 mm long and 400 mm into 400 mm in cross section is subjected to an axial stress of 100 megapascal along length and 40 megapascal on other two faces, all tensile. If change in volume is observed to be 125 mm cube find Poisson's ratio. Take E is equal to 200 kilonewton per mm square. Now here change in volume delta V is given, so and sigma x y z is given, so we will use the formula delta V is equal to bracket open sigma x plus sigma y plus sigma z bracket close into 1 minus 2 mu bracket close divided by E into V. Substitute the value. Change in volume given is 125, sigma x is 100 and sigma y and sigma z are 40, so 100 plus 40 all are tensile, so all will be taken as positive. 1 minus 2 mu, we want to find out mu, so substitute it as it is, divided by E is 2 into 10 raised to 5 Newton per mm square, so 2 into 10 raised to 5 into, put the bracket here for E and put the bracket here also for the volume. Volume is now length into cross sectional area, so length is 200 into 40 by 40. Here the dimensions are given 40, 40 and 200. So 200 into 40 into 40 is, this is the volume. Now how we do this calculation? What you have to do is 125, then this divided by this bracket, then E when it comes here it will get multiplied, V when it comes here it will be divided by. So 125 divided by bracket open 100 plus 40 plus 40 bracket close. This will become into, so into 2 exponential 5 divided by bracket open 200 into 40 into 40 bracket close is equal to, when you press is equal to you will get this figure 0.434, that is 1 minus 2 mu. Now you want mu, so what you have to do, 1 minus answer, press the answer button, is equal to, it will give you the value of 2 mu, then press divided by 2 is equal to, that will give you the value of mu, and the answer is 0.283. Here I am giving what are the buttons to be pressed. Try it once again. 125 divided by bracket open 100 plus 40 plus 40 bracket close into bracket open 2 exponential 5 bracket close divided by bracket open 200 into 40 into 40 bracket close is equal to, after that 1 minus answer is equal to divided by 2 is equal to, this will give the answer 0.283. If you are finding this little difficult, you can calculate this bracket, that is 100 plus 40, that is 180. You can also calculate this bracket 200 into 40 into 40, it will give you 320 exponential 3. Then what you have to do is 125 divided by 180 into bracket open 2 exponential 5 bracket close divided by bracket open 320 exponential 3 bracket close is equal to 1 minus answer is equal to divided by 2 is equal to, you will get this answer, mu is equal to 0.283. Let's take the next problem. A lamina of size 800 mm by 400 mm and uniform thickness is subjected to a stress of 200 megapascal tensile and 300 megapascal compressive along the axis bisecting 800 mm side and 400 mm side respectively. Find the change in sides if E is equal to 200 GPa and M is equal to 4. Now lamina is 800 mm by 400, so this is the lamina. X in the x direction it is 800 mm and the y direction is the vertical dimension 400 mm. Now for the 800 mm the stress is 200 mm megapascal tensile and it is bisecting the axis, so it is at the center here. Bisecting this 800 mm is 200 mm megapascal and tensile, so this is tensile force, and because it is vertical it is sigma y and it is perpendicular to the x direction. Now here, and for the 400 mm side is the 300 mm megapascal compressive. So for the 400, at the center of 400, that is bisecting the 400 mm is the 300 mm megapascal bisecting this width 400 mm. So at the center of 400 here at the center is compressive stress, and it is in the horizontal direction, so we are calling it sigma x 300 megapascal. Drawing this figure correctly is very important. So at the center of 800 is 200 megapascal tensile force. At the center of 400 it is 300 mm compressive. Now let m is given, so let us first find out the Poisson's ratio. The Poisson's ratio will be 1 upon m is equal to 1 upon 4, because it is given as 4, it will be 0.25. Then we want to find the change in sides, that is delta x and delta y. So for delta x will be sigma x minus mu sigma y divided by E into x. Here E I have taken common, substitute a value. Now sigma x is compressive, so it is minus, so minus 300 minus 0.25. Now 200 is tensile, so plus 200 bracket close divided by E is 200 GPa is 200 into 10 raised to 3. Keep it in the bracket, to bracket open, 200 into 10 raised to 3 bracket close, this is E, and x is the dimension, horizontal dimension, that is 800, so into 800. So let us do the calculations. Take the calculators in your hand and start from here. Bracket open, minus 300 minus 0.25 into 200 bracket close divided by bracket open 200 exponential 3 bracket close into 800 is equal to, you will get the answer minus 1.4 mm. This minus sign indicates that in the x direction there is decrease in length, so it is decreases. Then let us calculate change in y direction, delta y. The formula will be into bracket sigma y minus mu sigma x bracket close divided by E into y. Now sigma y is 200, it is tensile, so taken as positive. 200 minus mu is 0.25 into sigma x is compressive, so minus 300 bracket close divided by E is bracket open 200 into 10 raised to 3 bracket close, this is the E, into, now in the vertical direction y, length of y is 400, so y is substituted as 400. Start from here, do the calculations. Bracket open, 200 minus 0.25 into minus 300 bracket close divided by bracket open 200 exponential 3 bracket close into 400 is equal to. Now here you will get a positive answer, and it is 0.5 mm. Positive means there is increase in the length in the y direction 0 by 0.55 mm, and in the bracket write down increases. Here what is very important is, while substituting a value of sigma x, you have to take this as minus, and sometimes students, they don't remember that this is given as compressive and they take both the values positive. They write the formulas etc very correctly, do the calculations also correctly, but they forget to take minus sign for sigma x, and the whole answer goes wrong. So you have to be very careful whenever it is a compressive stress. Don't forget to take the minus sign. Let us come to the next problem. A metal bar of 300 mm by 100 mm by 50 mm is subjected to a stress of 80 megapascal tensile along x direction, 160 megapascal tensile along y direction, and 160 megapascal compressive along z direction. Find the change in volume if 1 upon m is equal to 0.25 and E is equal to 200 kilonewton per mm square. Now we want to find a change in volume. Directly use the formula delta V is equal to bracket open of sigma x y z is given, so bracket open sigma x plus sigma y plus sigma z bracket close into 1 minus 2 mu bracket close divided by E into V. This is the only formula which we can use and get the answer very quickly. Substitute a value, delta V is equal to sigma x given is 80 Sigma y is 160 tensile. These both are tensile, so plus 180 plus 160. Now in the z direction it is compressive, so minus 160. So sigma z, don't forget to substitute as minus 160 into 1 minus 2 mu is 0.25, so into bracket open 1 minus 2 into 0.25 bracket close divided by E is 200 kilonewton, that is 200 into 10 raised to 3 in Newton per mm square, into volume will be 300 into 100 into 50. So volume, this is bracket open 300 into 100 into 50, this is the volume. And start doing the calculations from here. Once you substitute the value, take the calculators in hand, and as you are watching the video, start doing the calculations so that you become used to using the calculators. At the last minute you will not be able to use the calculator in the exam. So here bracket open 80 plus 160 minus 160 bracket close into bracket open 1 minus 2 into 0.25 bracket close divided by bracket open 200 exponential 3 bracket close into bracket open 300 into 100 into 50 bracket close is equal to, check what is the answer you are getting. The answer is 300 mm cube. If you don't get the answer, repeat it once again from here. Bracket open 80 plus 160 minus 160 bracket close into 1 into bracket open 1 minus 2 into 0.25 bracket close divided by bracket open 200 exponential 3 bracket close into bracket open 300 into 100 into 50 bracket close is equal to. Here what few students do is they calculate epsilon x and epsilon y and epsilon z and then use the formula at volumetric strain is equal to epsilon x plus epsilon y plus epsilon z, and epsilon change in the volumetric strain is equal to change in volume upon original volume, and calculate the delta V. This is a very lengthy method, but if you do it by this method also you will get the same answer, but I feel that using this formula is very easy and you get the answer very quickly. Only thing is you should take this sigma z as minus and do the calculations very slowly and very correctly. So make a practice of using the calculators. Let us come to the next. A steel plate of size 360 mm by 220 mm into 30 mm is subjected to a biaxial normal stress as shown in figure. Find the strain in x direction and bulk modulus. Take E is equal to 204 GPa and mu is equal to 0.27. Now this is the stress stream given. In the x direction the length is 360 mm, in the y direction the length is 220. Sigma x is 140 tensile and sigma y is also 140 mm, 140 megapascal tensile. Now let us calculate the strain in x direction. Epsilon x is equal to sigma x minus mu sigma y bracket close divided by E. Substitute a value, bracket open, sigma x is 140 minus mu given is 0.27, here mu is given, into sigma y is again 140, both are tensile, so both the values are positive, bracket close divided by E is 204 GPa, that is 204 into 10 raised to 3. Put the bracket in the numerator and the denominator and do the calculations. Take the calculators in your hand and start pressing the button from here. Bracket open 140 minus 0.27 into 140 bracket close divided by bracket open 204 exponential 3 bracket close is equal to, here we will get answer. Strain in x direction is equal to 5.01 into 10 raised to minus 4. You may get it 0099. I have done the rounding, so 5.01 into 10 raised to minus 4. And both the stresses are tensile, so this is strain is also tensile. This is the strain in x direction. Now let us calculate the bulk modulus. For the bulk modulus, we will be using the formula K is equal to E divided by bracket open 3 into bracket open 1 minus 2 mu, first bracket close, second bracket close. Substitute the value of E is equal to 204 into 10 raised to 3, put it in bracket divided by bracket open 3 into bracket open, 1 minus 2 into 0.27, first bracket close and second bracket close. Start doing the calculations from here. Bracket open, 204 exponential 3 bracket close divided by bracket open 3 into bracket open 1 minus 2 into 0.27, first bracket close, second bracket close, is equal to, you will get the answer 147.826 into 10 raised to 3, and it is in Newton per mm square or megapascal. Now here few students, what they do is, for a biaxial stress system they calculate change in volume, and then they use the formula K is equal to sigma divided by volumetric strain. But let me tell you, you cannot use this formula here. Why? Because when you use this formula, this stress sigma has to act on all the three axes. Here sigma x and sigma y, they are 140, they are and tensile, but this is a biaxial stress system, so sigma z is 0. If sigma z would have been tensile 140 megapascal, then this formula will give you the correct answer. But here sigma z is 0, so this formula you cannot use. And if you are using this formula and calculating the epsilon v for the biaxial stress system and then substituting sigma as 140, if you calculate K, your answer goes wrong. So you cannot use this formula. For when you want to use this formula, the stress sigma has to be there on all the three axes. This is very important to remember. So you have to use this formula. So which formula to use in the exam becomes very important. Few more problems we'll see in the next video. Be a master. Thank